actually starts. So the near, in quotation marks, future space travel, and you'll see why I say near in quotation marks here in a second. So today we're kind of gonna go for what near is referring to. Then we're gonna talk about like Earth orbit, what's gonna be happening, then the moon, then the asteroid belt, and then Mars and beyond. I know the asteroid belt is technically in between Mars and Jupiter, but I have more stuff to talk about the asteroid belt than I do for Mars. That's why I grouped Mars with the beyond instead of the asteroid belt and beyond, which would make more logical sense. You guys get it. All right. So, what do I mean when I say near? Well, I mean like in the maybe like 50 to 100 years, which is not really near, but in the grand scheme of human history, it's a pretty short time. Because when you think about the changes that happened between like 1800 and 1900 or 1900 and 2000, it was just enormous changes to the way of life of almost all humans. So it's near in the grand scale of things, but these are pretty massive changes to how humanity's working here. All right, let's hold back on the discussion about the differences between Minecraft and Genshin Impact, and let's focus, zero back in on what we're talking about here. All right, so, oh, and then I guess we're all stuck about Venus. I forgot to put that in the overview. Yeah, Earth orbit, and then one slide on Venus. So, Earth orbit, and Venus. So, the first thing, well, not first thing, but one of the things that's going to happen in the next like 100 years or so, there's probably going to be a lot new space stations and satellites. So the ISS is going to eventually deteriorate, where it's going to fall back to Earth at some point, or it's going to become old enough where the cost of maintenance is not going to really be worth it, and so we're going to see the ISS deteriorate, and we're going to have a new International Space Station, hopefully, but maybe not, because the age of international cooperation in space is probably going to start kind of falling apart once climate change starts hitting everybody. So, but yeah, we'll see. Yeah, so we're also probably going to see new purposes for space stations, whether that beyond just like the scientific purpose that we currently see with space stations. We're probably going to see like military stations. We already have military satellites, not officially, but we have military satellites. And we also as in like satellites equipped with weapons to take down other satellites. But yeah, those definitely exist, whether or not like people say they exist. They exist. Then we're also probably going to see like industrial stations, where we make things that might work like in industrial capacity, where it's not worth it to it's not worth it. It's easier to create in 0G than it is on the using Earth gravity or microgravity, not 0G. Because it might, for a variety of reasons, that could be the case. But industrial capacity and in Earth orbit is definitely going to be something that happens, whether that be whether that be in the next 20 years or the next 100 years, like I said. So yeah. Then also we're probably gonna see dockyards in space. That was a weird way of saying dockyards. But the reason for that is because it's way cheaper to make like a rocket if it's already escaped Earth orbit. If you remember from last week, we talked about how quote unquote expensive it is to escape Earth, and especially just get into Earth orbit. It takes a lot of energy, So it's a lot easier if your rocket just starts in Earth orbit rather than being created on Earth and having to get to Earth orbit. But that's going to require some other things for that to happen, namely like asteroid mining and the like, because you would still end up having to ship the materials up there somehow. So then we're also going to definitely see competition.
I have a question.
Yeah.
How did they get the picture of the ISS?
Probably from an astronaut or from a yeah, probably just from an astronaut. Then also competition in space is definitely going to increase. We already see India and like China flexing their anti-satellite missiles from Earth. And so that kind of competition where we're trying to be the first like people that have stuff in space and Earth orbit's going to definitely increase. For example, China and Russia and the EU are creating new GPS systems. So because the current GPS system is run by the US military. So if we wanted to, we could just cut off GPS access to anybody we wanted to. So that's why all these countries that are pretty powerful want to have their own GPS system so they don't have to rely on the US for their own. And so that kind of competition where people are creating like their own independent systems and all that in space is definitely going to increase in the near future. Oh. Let me just check something. What Asia Association? Wait, when did I say about the Asia Associate? Like, wait, ASEAN? Like the Southeast Asian thing? Richard, can you specify more about what you're asking before? Yeah. All right. There's a question I was a little confused about in chat here. All right. So another thing could be the space elevator. There are a lot of problems with it, but the reason why we would want a space elevator
Is it me or are you lagging?
Or he's completely.
It's just him.
Oh, he's lagging. He's lagging.
No, he's frozen.
He's lagging to me too. It's lagging.
He's lagging basically means he's frozen.
Prepare you guys to hear a very fast. No, he's not
yeah,
lagging.
it says my internet connection is unstable.
He's back.
So okay. Yeah, it's raining, so that must be part of the reason or something. But yeah, my internet
I knew it was raining for you.
Kind of pooping its pants here. All right. Hopefully that doesn't happen again. If it does, just like say something in chat or something, or just unmute yourselves like you did. All right. So a space elevator. Why would we want one again? So a lot of it's way cheaper to use a space elevator than to create a rocket. Or even a reusable rocket. It's still more expensive than just having an elevator that would bring you from the surface of the Earth to the Earth orbit. Also, for those unfamiliar, a space elevator is a concept that would literally be like an elevator that goes from the surface of the Earth to Earth orbit. So you just kind of hop in, and you could go, or you could like use for cargo to just bring things from the surface of the Earth to Earth orbit very quickly and very cheaply. So there are a couple of problems with it. So the physics problems are that the forces that this hypothetical elevator would have to would be experiencing would be amazingly difficult to deal with from a material science standpoint, because simply the it's going to have to be many, many miles long, and so it's so the speed at which it's rotating is going to be way higher at the top than the bottom because the way circles work, and so it's going to have to be able to withstand many forces there, and then it's also going to have to deal with winds from like the jet stream and a bunch of other things that are very complicated physics problems. But theoretically, if we found the right materials, it could be possible, and that's where the material science problems come in. So the biggest thing with the space elevator is what materials would be able to be made. What materials do we use to make it? So some people would say carbon nanotubes because, I mean, yeah, they probably would work, but the big problem is that we can't really make them in large quantities right now. But if we used standard materials like steel or titanium or aluminum, they wouldn't be able to withstand the forces that a space elevator would undergo. So yeah, we kind of need this kind of numerical material that would be able to withstand all those forces, which we do not have. So runs into some problems there. Yes, this was talked about in Kerr's Gazette, by the way, if you are interested. A lot of the stuff was talked about in Kerr's Gazette. Because Kerr's Gazette covers like it's cool to talk about the future of space. So all right, so huge problem though with the future of space travel is space debris. So there's currently about 20,000 trackable objects in Earth orbit right now, but that's trackable objects. There's about estimated to be 128 million objects that are smaller than a centimeter in Earth orbit. So how do those form? They can form from anything really. They can form from a satellite just kind of breaking down, a satellite running into another satellite, which has happened before, a rocket hitting a satellite, or a rocket hitting a smaller piece of space debris, a missile hitting a satellite, an asteroid or meteor hitting anything really. Just the list goes on. So why are these a bad thing? Because the danger that they pose to satellites and other spacecraft are just immense. So a little like 1 centimeter small thing that impacts a rocket or a space station or a satellite will rip a hole in it almost. Oh yeah, Viking. Have your hand up.
So are we going to talk about the pollution out there?
Climate change and stuff. We're not
No,
gonna
the pollution out of space, like in space.
like what we're talking about now, or like pollution as in like chemicals and stuff.
No, I mean the pollution. People cannot other countries cannot pick up stuffs that are not from their countries.
Well, I mean, no, I don't think we're gonna talk about that thing, but we're talking about kind of the pollution of space in the sense that we might not be able to in the fact that we're talking about the space debris right now. But nothing like about countries not being able to pick up space debris. So yes. So, and the harm that they pose to satellites and spacecraft is just enormous. So, just look up images of like a space debris impact or something like that, and you'll see just terrible images of how little small things can just create giant holes in spacecraft and space stations and satellites. And the huge problem with that is is that when a little piece of space debris impacts something, it creates more space debris. So if two satellites ran into each other, which has happened before, that you go from like two pieces of debris, so to speak, and then it becomes thousands upon thousands of pieces. And then those pieces can impact something else, and that creates more, and that can impact something else, and that creates even more. And so it just goes into a loop until you have so many pieces of space debris that you have that Earth experiences what's called Kessler syndrome. So Kessler syndrome was like the idea was created in the 1970s, and it's essentially saying people would not be able to escape Earth because a rocket trying to escape would run into so much space debris that it would get annihilated on trying to escape Earth. And the same thing, satellites would not be able to exist because there's so much space debris that everything just impacts it as soon as that happens. And so we are essentially trapped on Earth, unable to escape it or put anything up there. So a lot of problems. So yeah, so space debris is a huge problem. All right, Venus. So Venus has no tectonic activity, so it'd kind of be hard to shape to our will, so to speak, because a key thing in being able to sustain life turns out is tectonic activity, because it creates continents and large oceans and needed like breathing of the Earth. And so that when there's no tectonic activity, it's hard to sustain life. So yes, Grace, there are a lot of problems about space travel. And also Venus is very dangerous for anything man-made beyond just like the sulfur rain. So the atmosphere of Venus is made out of sulfur dioxide and many very dangerous chemicals. There is no such thing as normal rain on Venus. It's always acid rain. And the Soviets sent they sent one probe onto Venus to like take pictures of it and see just what Venus was like. The thing managed 2 pictures and then died. And this was a little like robot probe. So imagine what it would do to organic life. So very inhospitable. And so any terraforming activity that we would do would probably take hundreds of years. So not really fitting within the time frame of a near future thing in space. So Venus, pretty off limits. People like to say it's Earth's sister planet, but it's like the evil twin of Earth. Earth is very hospitable, and it's where all life in the solar system is as to our knowledge. Venus is like, it kills anything that touches it. So, and the reason that it's like this is because of a runaway greenhouse effect. So, the thing we're experiencing right now, greenhouse effect. Venus had a really, really bad version of a greenhouse effect and now it is the closest thing to hell that we have seen. So, yes. All right, now let's go on to the moon. So, a moon base, because who doesn't want a moon base? But yes, we talked about a little bit about it last week and how it'd have to be on the South Pole because of a variety of reasons, such as like access to water and the fact that it would have 24/7 solar energy. So yeah, that's just a little bit about it. But then a moon base is estimated to cost anywhere between $10 and $30 billion of an initial cost, and then about $7 billion of upkeep. However, the high end of that towards $30 billion and that $7 billion of upkeep those are estimated without any in situ resources being used. However, that is unrealistic because then what that means is that that $7 billion upkeep figure is saying we're shipping stuff from the Earth to the moon to have so the moon can have every resource it wants or needs. Whereas realistically, we would be using a lot of resources already on the moon to function. So that $7 billion probably a lot lower than that. And a moon base, though, would be super useful because it could serve as a jumping off point, so to speak, for a potential further expanses into the solar system, because it's easier to get out of lunar orbit than it does to get out of terrestrial orbit or Earth orbit. So so what you could do is have almost like a shuttle between the moon and the Earth, where it would be a pretty reusable rocket going between to get personnel between the Earth and the moon, and then you could manufacture most of the bigger rockets on the moon to get to like Mars or something. So that would be very useful. Then also the moon could be a center for research in lower G orbits at a larger scale. Currently, we have microgravity research going on the ISS. However, that is a relatively small scale. The moon base would allow us to have larger scale of that. This image really quick on Lunar Mining this is really silly because there would just be moon dust everywhere from the way this miner works, and so the mining would not look like that. I just thought it was so funny that I was going to keep it. So lunar mining, the moon has a plethora of resources, so it would be pretty profitable once you figured out how to get the resources out and process it all. But it could be pretty good for in situ uses of the minerals already on the moon. And again, it could be self-sustaining because a moon base could use all of the resources it needs for upkeep and expansion just from stuff that's already on the moon. Then there's also it could be the materials on the moon. It could be a source for Earth or lunar projects. That kind of speaks for itself. So then a huge thing that the moon offers is the hypothetical mooncrete, which I talked about a little bit. And mooncrete just sounds funny, but also could be really useful as a structural material in a moon base, because it's just being made out of the kind of dust and all that stuff that's already on top of the lunar surface, and just turning it into concrete, essentially, that would be able to be used for construction at a very low cost. All right. So then could end up being like in 2001: A Space Odyssey, where there's a black obelisk on the moon that leads us to a wormhole at the edge of the solar system, and it leads to the further enlightenment of humanity. It's a very good book, and I haven't seen the movie yet, but the book is very old, but it's really good.
What's it called?
2001: A Space Odyssey. I'll put that in chat here. There you go. Oh yeah, by the way, guys, I forgot to mention this. So if you guys are interested, I put in the Discord channel for space travel 2 links that will show maps of the Earth and all the space debris around it. So pretty interesting. You guys check it out after this class. But yep, let me get the link. I'll put the links in the Google Classroom as well, but along with the slides for this. But yeah, the links are pretty interesting, so you guys can check it out. All right, so the asteroid belt. I'm gonna have to get a little faster here for time for the COOT. So, asteroid mining. So Let me wait. Probably not, Sam. All right, asteroid mining. Yeah, well, the thing is, Kurz Gazette has made most of videos for most topics about the near future of space travel. So you can't really have like things that haven't been covered by Kurz Gazette. Like I haven't watched. I'm not taking my information from them. I'm just like they're similar ideas because Kurz Gazette covers a lot of things that about space. And so yeah. Anyway, asteroid mining would be super useful because, for example, about a year ago, NASA discovered an asteroid that could be worth 10,000 quadrillion dollars, or about 10 quintillion dollars, which is more valuable than the entire global economy right now. So that would be interesting. Then they could be used. So actually, not could be. So the big problem with asteroid mining would be like transportation. So would you be mining at the location of the asteroid, or would you be mining? Would you tow them back to Earth orbit and then use that for mining? But that could lead to a problem because you would have all these massive asteroids that right above Earth orbit that anybody at any time could you just like kind of nudge, and then they would be going towards the Earth at a very fast pace, and could extinguish life on Earth as we know it. So that'd be pretty risky. So, but also you could do a variety of things with them to mitigate the risks. But still, so what the question of how to actually get the resources from the asteroid to Earth, a lot of different ideas. So then the asteroids that if they were to be in Earth orbit, or even if the materials were towed back to Earth from the asteroids, they could be used to construct spacecraft. Because if going back to the dockyards idea, come on. Going back to this dockyards idea here in Earth orbit, then could be a way that we get the materials needed to construct spacecraft without having the spacecraft have to be able to leave Earth orbit. So we could just construct them from asteroids, materials found in asteroids, within Earth orbit already, without needing to get the materials onto Earth first. So then the materials on asteroids could also be used to sustain life on extraterrestrial bases, because a lot of asteroids are made out of water, or have a lot of ice in them at least. And so that could be a method of obtaining water for extraterrestrial bases, and also could be a source of minerals and other materials that are needed for construction and upkeep and all that. So, yeah. Then Ceres is an interesting object in the asteroid belt. It's the largest object, and it's very rich with resources, but the most important part is that it could serve as another base for humanity. So a big thing with space travel is mitigating the cost of space travel. So if you can make it so you don't have to have an enormous rocket carrying an enormous amount of fuel to go places, that's really good, because then you don't need to have to engineer your way into having a solution. And instead, you can just have a series of smaller rockets. So you could have a rocket from Earth to the moon, or Earth to Earth orbit, and then Earth orbit to the moon or something, and the moon to Mars, and Mars to Ceres, for example. And that would be probably way cheaper than just having to engineer yourself an enormous rocket with an enormous amount of fuel to reach Ceres in a reasonable amount of time. Of course, you could use like ionic boosters to get to Ceres, but that would take way longer than what would be really realistic. So, and just like the reason that would be useful, that series could serve as another base and the hub, is that the sheer expanse of the asteroid belt is often underlooked. So the asteroid belt is enormous, and so going from using Mars as a jump off point to the rest of the solar system would not really the gas giants and all that would, yes, that could happen, but it's not as feasible as using Ceres as that, because then you're already halfway of the way to Jupiter, kind of. And so also just a quick note is that the asteroid belt is not like what you see in like Star Wars, for example. At the asteroid belt there are many, many, many miles between asteroids and the asteroid belt, even up to like tens of thousands of miles between asteroids at some points. So it's not very dense like what people might think from Star Wars and all that.
But at least it's denser than other areas, right?
Say that again.
It's at least denser than other areas, right?
Yeah. So the asteroid belt is like, it's, what I mean is that it's it's dense in that there's more material than like open space, but it's not like what you see in the movies where it's kind of asteroids every couple feet. It's every like 100 miles or something. Like you can't really see the asteroids. But if you were on an asteroid, you couldn't see another asteroid. So that part's unrealistic. So all right. So let's talk about Mars and the gas giants. So the only thing about Mars that really here is that we could have a Mars base, and there are a couple problems, as there always are. So there are a few accurate cost estimates for what a Mars base would actually cost. So we don't really know all that. We know like what it would take to get to Mars, but establish a base is really more up in the air. Then also, is it really sustainable? So could we make food on Mars? Maybe. Could we could we use the materials on Mars to construct the base? Again, maybe. And then also sustainable in the fact that long life on on Mars is very dangerous for your health. So there's a number of physiological impacts. What that means is just kind of like your body is gonna kind of go to crap. So that's because living in low gravity is really dangerous for your muscles and bones, because you've evolved specifically for Earth's environment, Earth's gravity and all that, and living permanently in a base on Mars really not healthy for you. Your muscles are gonna atrophy, your bones might weaken, a lot of bad problems. And so then also you might experience really bad loneliness. Humans are social animals, and when you're spending the entire rest of your life trying to living with the same like couple, maybe dozen people or something, it's not good. So for your social health as well. Then economic usefulness. Yes, a Martian base could serve as a base for research and a jumping off point again for the rest of the solar system, but does it have as many resources as maybe a Mars base would, or is it really as useful as a moon base, not a Mars base. I'm talking about a Mars base. Would it be really as useful as a lunar base, a moon base? Maybe not. Maybe it is. I don't know. There hasn't been enough research into it. There hasn't been as much research into it as a lunar base. So, Samoyeds are super cute. All right. Then let's talk about the moons of Jupiter. So Io, it's probably unlivable. It's pictured here. There's a lot of sulfur going around. That's that yellow, green, and red stuff and all that coloration. That's from sulfur and other toxic chemicals. Probably not the most ideal place to live. However, Ganymede, it's the largest moon in the solar system, and it has maybe it has an internal ocean and has an oxygen-rich atmosphere, which is pretty good. Europa is also a very good candidate for a human settlement. It has liquid oceans potentially, as a pretty similar climate to Earth, and it could be, and it has a kind of, it has similar. Sorry, I'm trying to think. It has like if you look at a picture of Europa, it has it is I believe it has like streaks across the surface that are riverbeds. I'm fairly certain. Unless, yeah. So then there is Callisto. That's another planet, another moon of Jupiter. All these are, by the way, the Galilean moons, which were discovered by Galileo Galilei in like the 1600s. So that they're like the most famous Jovian moons. So anyway, Callisto. There's no plate tectonics on Callisto, which is pretty bad. And that's because plate tectonics, again, they're like the kind of natural progress process that plate tectonics cause will generally benefit life, the sustainability of life, because it creates like continents and oceans, and it creates a more uniform planet, or moon in this case. But however, there have been organic compounds that have been identified on Callisto. So yeah. All right, then Titan. So Titan has an Earth-like climate and an Earth-like atmosphere, and is about the second, and it is the second largest moon in the solar system. These are the moons of Saturn, by the way, not Jupiter. We moved on to Saturn. And so Titan is probably the best bet we have for a settlement of humans beyond the asteroid belt. And for good reason, because it's the most Earth-like place probably out there in the solar system. Then Enceladus has a high albedo, which means that it reflects massive amounts of light that touches it, and so that makes it enormously cold. It has temperatures like negative 200 degrees Celsius average, but there have been water plumes on it that indicate that it could theoretically support life because there's liquid water. And so pictured here is Enceladus, and so it's very white because it's covered completely in ice. So it's very, very cold, but and the reason that it has a high albedo is because of that ice. So that it got cold, then the high albedo ensures that it stays cold. So that it's a self-sustaining
So
cycle.
essentially, like the opposite of a greenhouse gas thingy, whatever.
Yep, exactly. Yep, and so yeah, big takeaway from here: Ganymede and Europa could be pretty good for human settlement, and then Titan, definitely a lot of people have their eyes out on that. All right, and now let's get towards the COOT. I think I timed that relatively well there. All right. I forgot to share audio, so just give me a second. I already logged in. I don't know why it keeps bringing me to the screen. All right, let's press play, host. Also, you guys, there's a pretty good movie that has a Martian and a lunar base called Ad Astra. I'll put that here. That movie, super good. One of my favorites. Yeah, you guys should watch it. It's really good. Yeah, Wally is pretty good too. All right, we're gonna get started around 7:47, so you have about 15 more seconds. Oh, that's a lot of monkeys. Highest participation so far, though. We have 16 people. Nice job.
Wow. Why is there only 6 problems?
Because I couldn't think of too many.
I clicked the wrong thing over and so bad.
Ah, rip.
Is it still raining for you? It is.
Why is your name all cap?
Ooh, yes, it's called Kessler syndrome. So
Not being
the
able to
reason
have
that-
satellites.
the reason not being able to have satellites is not the correct answer here is that it's not telling the entire story because we probably would not be able to leave Earth at all, not just being able to have satellites. That is one part of it, but it's not the entire correct answer.
I was gonna pick that, but I accidentally clicked on Tyson syndrome because it also had syndrome, and I knew it was a sort of syndrome.
Yeah, Tyson, I just picked the name of an astrophysicist, Neil deGrasse Tyson, and put syndrome after it.
Oh, Rick asked you.
I remember in situ resources are resources that are on the in place, like they're in where. So in situ resource on the moon.
Mooncrete.
From
Concrete, but it's mooncrete. Yeah.
let's
Don't choose Mooncrete.
avoid discussing the question answers when yeah.
Oh, I what? I got it wrong. No.
Dang, yeah. So mooncrete. Yeah, mooncrete would just be used. So it says in situ resource that the moon base can be made out of. PLA plastic, steel, and carbon nanotubes are not in situ resources for the moon. So especially carbon nanotubes, especially because carbon nanotubes are super hard to construct. So yeah, pretty difficult.
Do you like anime?
I would say I have watched
What's
my
that?
fair share. Nice job, guys. Yeah, nice job. Runaway greenhouse effect.
Your mom.
Seriously?
Yup.
Seriously?
Nice job, everybody. 100% correct. That's what you like to see.
Seriously. I don't know what that's called. It's probably a pun or something like that. Lonely. String something.
Ooh, yeah, this was a difficult one. So
How is it not loneliness?
it says which is not a risk.
Oh! Whoops.
Yup. So gotta read the question.
Wait,
Yeah.
actually, no, it is loneliness. Loneliness is not a.
So yeah, running out of the money for the program is probably not going to risk the health of a crew.
Oh.
So, because there would always be enough funding to get the crew out of there if necessary. So, that's a good pun, Alvin. Serious. That is a really good pun. That's okay. Applause for Alvin's pun. That was so funny. Okay. Ooh, make you cry. Falling out of first place.
I just realized enchiladas kind of sounds like enchiladas.
Yeah, you could say Enceladus sounds like enchilada when you pronounce it a
It
certain
sounds
way.
like Latin. Enchilada enceladus.
Rick Astley, never gonna make you cry.
Make you cry and
Never
never
gonna
gonna
make you
run
cry.
that first place.
So don't say goodbye.
Nice job, everybody, for participating.
Hey,
Let's see, 40% average correct. We can always I get a couple doozies in there. But yeah, nice job, everybody that participated.